For number 15, we want to choose two numbers that when we multiply them together, product means multiply, the answer is rational, meaning you don't want a root. So I'm just going to open up a box here to represent the first number, multiplication symbol, in our second number that we choose. And our answer needs to be rational, meaning we don't want a root. So if I were looking at this list, the first thing I would try to choose is two numbers that are not roots, meaning two rational numbers, and the only rational number here is the -7. So that easy choice is not going to work. So that means we're probably going to have to choose two roots together, because if I choose a rational and an irrational, meaning if I choose -7 and any other number in this list, you will be stuck with the root because you're multiplying two opposites, and the root would never disappear. However, we showed in class that you can actually choose two roots and you can have that turned back to a whole number as long as the radicand is a perfect square. For instance, I'm trying to figure out what two numbers I can multiply together to get a perfect square. For instance, 8 and 2, if I multiply that gives me 16. That's an option. If I multiply 2 and 12 together, that would give me 24. That's not a perfect square, so that would not be an option. If I multiply 12 and 8 together, that would give me 96. Again, not a perfect square, so that's not an option. And if I multiply, say, something like the square root of 8 times 3 over the square root of 2, that would actually work. So the square root of 8 times 3 over the square root of 2. How come this is rational? Well, remember, the only part we care about is simplifying the roots if we're deciding rational or irrational. So let's put a 1 under this so they're both fractions. If I multiply straight across only looking at the roots, I would have root 8 in the numerator and then root 2 in the denominator. And I can divide that. 8 divided by 2 is 4, so that's the square root of 4, which is 2. So that's one option. Another option would have been what we said in the beginning, the square root of 8 times 5 square root of 2, because 8 times 2 is 16. So that would give you another perfect square, just looking at the roots. And another option would be the following. You can multiply 5 root 2 times 3 over root 2, and the reason this gets rid of the root is if you create a fraction in the first term by putting a 1 under, and if I multiply straight across, all I care about is the roots, so there would be root 2 in the numerator, root 2 in the denominator, and if you reduce that, it's just 1, so that would also be rational.